We are delighted to announce the release of Spark version 10.6, our bioisostere replacement tool, which contains improved search methods for refined molecule design, a new docking methodology, and much more. In this version of Spark, we've enhanced the existing search methods, meaning that Spark will present more results with promising bioisostere factor at the end of an experiment. In terms of how these improvements have changed the Spark GUI, within the scoring section of the advanced search options, you can now find a take more fragments into second scoring pass option. We've also added a very accurate but slow search method in the list of calculation methods. When selected, this search method uses both shape and field scoring in the first pass, increasing the accuracy of the fragments sent to the second pass. Finally, for experiments that start from a protein-ligand complex, we have optimised the use of the protein as an excluded volume. In our in-house validation, we have found that for a typical R-group replacement experiment, these enhancements can lead to the identification of up to 30% more results with a promising bioisostere factor. A new docking feature is now available as an add-on module to the traditional Spark bioisostere replacement methods. This feature works for R-group replacement and ligand growing experiments by removing the atoms that have been selected to be replaced, placing the new substituent in a sensible orientation within the active site, avoiding steric clashes and guided by protein electrostatics. Then the pose is optimised with Lead Finder using a score-only docking mode. The best results from this process are prioritised by the Lead Finder rank score, the scoring function that is optimised to reproduce the crystallographic pose. Spark docking experiments are more computationally intensive than the traditional search methods, so in order to reduce search times and improve the accuracy of your results, we recommend applying your knowledge of the preferred physical-chemical profile of the fragments you want to find via the size criteria and advanced filter search options before running your experiment. For example, via the size criteria window, you can limit the heavy atom count or the molecular weight of the result molecules. Via the advanced filters, you can define a range of allowed lipophilicity values and polar surface area values for the result molecules. As well as the major enhancements made to Spark that I have already mentioned, we have made a number of additional improvements to the Spark GUI in order to further improve the user experience. Sign up to our newsletter to receive monthly computational chemistry updates. If you'd like to find out more about accessing the Docking in Spark feature, or to organise a Spark evaluation, please contact our inquiries email address.